Hi, Mr. Sapone here, and I'm bringing you one of my very ridiculous mole density problems. Um, and the question is, if I were to give you one atom of gold for every second that has elapsed since the dinosaurs went extinct 65 million years ago, how much gold would you have? Assume the density of gold is 19.3 grams per centimeter cubed. So I want to know what volume of gold, what size gold you would have, assuming that I'm giving you one atom of gold for every second that went by in the last 65 million years. And this is a very involved problem. And let's give us a little canvas to work with. And the first thing we need to realize is I'm asking you for a volume of gold. And I also gave you a density value. So that should give you a hint on how to solve this. Density equals mass divided by volume, and I'm asking you to solve for volume. So we know we can bring the V up, we can bring the D down, and volume equals mass divided by density. And in this case, I give you the density value. So I'm asking you to give me a volume of gold. The volume of gold, AU, volume AU, will equal the mass of the gold we have divided by 19.3 grams per centimeter cubed. Wonderful. So now all we got to do is figure out what mass of gold we have, considering that we have the number of atoms of gold. Well, we're going to have to figure that out too. But to clean this up, this is the formula we're going to work with. And basically at this point, we're looking for the mass of gold. So I kind of threw that in here in the formula. So the first thing we need to realize is that I'm giving you one atom of gold for every second that goes by. And a total time of 65 million years went by. So what you really have to do is you have to convert 65 million years into seconds. And that'll tell you the number of atoms of gold you have. So we take 65 million, and that's going to be 6 zeros, years. And we're going to multiply that by 365 days per 1 year. And these years will cancel. And we want to get rid of days too because we want to go all the way into seconds. So we're going to multiply this by 1 day over 24 hours. And again, these days are going to cancel. And we want to go from hours into minutes. So we're going to have 1 hour is 60 minutes. Hours are going to cancel. And then finally, we're going to go into seconds. Minutes are going to cancel, and the final unit we're left with is seconds. So really what you got to do is multiply across 65 million times 365 times 24 times 60 times 60. And that gives you the number of seconds in 65 million years, basically telling you how many seconds there are in 65 million years. And I'm telling you that I'm giving you one atom of gold for every second. So you're going to have that many atoms of gold. And when you get that answer, it should be about 2 times 10 to the 15th atoms of gold. So this is how much gold you're going to have. AU. So now we know how many atoms of gold we have, but we still have to figure out the mass of gold. And what we're essentially going to do is we're going to convert atoms into moles using Avogadro's number. And then we're going to convert the number of moles of gold we have into grams using the molar mass of gold. And I have argon written up here. I made a little boo-boo there. This should be gold, of course. So we have 2 times 10 to the 15th atoms of AU, or gold. And I'm going to multiply this. And I need to use Avogadro's number. So I know that 6.022 times 10 to the 23rd atoms of AU is going to be equal to 1 mole of AU. Because why? Well, if I had this many atoms of anything, it's equal to 1 mole. 6.022 times 10 to the 23rd atoms of silver is 1 mole of silver. So I can, these atoms of AU are going to cancel. And essentially I multiply across 2 times 10 to the 15 times 1 is 2 times 10 to the 15th divided by Avogadro's number. So I put this number in my calculator, divide it by Avogadro's number. And this number is much, much smaller than this number. So I hopefully realize you're going to get a very, very, very tiny number. And when all said and done, you should have something about 3.4 times 10 to the negative ninth moles of gold. So that's how many moles of gold you have. So we've gone from the number of atoms of gold using Avogadro's number to the number of moles. Now we have to go from moles into grams using the molar mass of gold. So we have 3.4 times 10 to the negative ninth moles of Au times. And I know that 1 mole of Au is 197 grams. That's what this bottom number means in the periodic table. And that is rounded slightly. 197 grams of Au is 1 mole of Au. So this mole of Au cancels. And essentially I'm multiplying these two numbers. 3.4 times 10 to the negative ninth times 197. And that's going to equal 6.7 times 10 to the negative 7th grams of Au. And that's actually the mass I'm looking for. So I'm going to take this number. This is the mass of gold I have. I'm going to plug it into this formula right here and solve, and I'm done. So volume equals 6.7 times 10 to the negative 7th grams of Au divided by 19.3 grams per centimeter cubed. And of course, the grams are going to end up canceling. We're going to be left with just centimeters cubed. And that's going to equal 3.5 times 10 to the negative ninth centimeters cubed of Au. And that's going to be a very small volume of gold. I'm a little thrown off by that, but yeah. So anyway, this is going to be the volume of gold you're going to have if all my calculations are correct. I know the process of doing it is 100% correct. And this volume, actually, the dimensions of it are going to be smaller than the visible eye can see. So that kind of gives you an idea how many atoms there are in something. If I were to give you 1 atom for every second that elapsed since 65 million years ago, you're not even going to have a quantity of gold that you can see with your visible eyes. It's going to be that small. It just shows you how big Avogadro's number actually is. And that is our final answer. And this is a very involved problem, and you're going to get one with a slightly different number on your test. I'm going to remove the 65 million. Sometimes I use 200 million and other things like that, Pangea. But basically to solve this, we're using the formula, volume equals mass over density. And we know density, but we need to find M. So first you convert the number of years you have into seconds. And the seconds equals the number of atoms of gold you have. You then convert atoms to moles using Avogadro's number. Then convert moles to grams using the molar mass of gold. And you plug the mass value into the formula and you solve it. And that gives you your volume. And I know this is a very complicated problem, but try it, sit there, go through it step by step, look at it. It is only algebra based and conversion factor based, so you can figure this one out. Hopefully that helps you get a better grade in the test. This is Mr. Sapone. I'm out.